Okay, this is the second part of the Footscan Prac. In this specific video, we're going to be looking at the data analysis component. So the purpose of your prac is to be able to determine whether there are significant differences between shod and barefoot conditions and between walking and running conditions. Okay, so in order to get to those answers, we need to run some inferential statistics. And in order to get you guys to be comfortable with that, I've just thought I'd put an example together with some fictitious data and get you guys to practice some of that stuff so that it makes the analysis that you guys are doing a little bit easier to understand. So here I've got 3 different groups that can be representative of any data that you guys might be looking at this point in time. In these groups, I've if you work out the mean or the average for each of these groups, I've purposely worked it out in a way that they are pretty much equal within a few decimal points of each other. These are just rounded up values, but I guarantee they're very close. You can see here in this graph that it's not quite a straight line, but it's pretty close, right? The thing that I wanted to highlight though is that even though the means are the same, how that data is distributed relative to the mean is not the same. There's quite a large amount of variation or spread of the data relative to the mean. So you can see here in group 1 there's a lot of variance, a little bit less in group 2 and the least in group 3. In other words, the data in group 3 is it's fairly closely packed to the mean. So you can see here that it ranges between 9 and 10, averages by 10, so there's a small amount of variation in terms of the standard deviation, or the deviation of that data around the mean. But in group 1 that's quite large. So there's 2 things that we need to answer. One is based on the assumption that your data is normally distributed, which we're not looking at now. That's a little bit beyond the scope of this, but we're making that assumption for now. That you want to assess whether there's enough evidence to show that the variance between 2 groups is not significantly different. In other words, that's your null hypothesis. The null hypothesis for this states that the means between these two, the variances between these 2 groups are equal, right? Which we can clearly see is not the case, but we need to obviously be able to prove it. This is a very clear example, and your data sets that might not be as obvious. Okay, and the same thing, we'll compare group 1 to group 2, group 1 to group 3, and then finally group 2 to group 3 in order to definitively answer that. The second thing that we have to do is run a t-test to determine whether the means are equal to each other, right? In essence, that again your null hypothesis for the t-test to state that the means for each of these groups are not significantly different from each other, and then we'll see if there's enough evidence whether or not to accept or reject that specific hypothesis. Intuitively, you should visually see that the variances are different, but the means are not different. So we'll see if the data kind of represents that. That's why I chose this kind of an example, because intuitively it should make a little bit more sense. And then you can transfer that intuition, in essence, to your prac. Okay, so there's a long way and a shorter way to do it. The longer way might be a little bit maybe more familiar to you guys. The shorter way involves just writing a few formulas out, but I find it's typically a lot quicker. Okay, so let's start off with the f-test. So in order to do the f-test, you've got these tabs up here. Go to the data tab, go to data analysis, go up here to the f-test, right? F-test 2 sample for variances. Click OK. I want you to, for variable 1 range, highlight group 1, or that might be your metatarsal 1, for example. Just highlight the name of that specific variable as well as the numbers. Press enter. Then do the same thing for your variable 2 range. This is the second group that I'm comparing to. Press enter. Make sure that your labels option is highlighted. So for many of you that won't be, keep the alpha level at 0.05 and then select. It's normally on this new worksheet option. So just select the output range and select the cell where you want to put that information. So I'm going to choose Q3 over here. Press enter and then hit OK. So what we'll see here is a bunch of data that gets spit out. Firstly, it'll tell you what the mean is, which we've already determined. It'll also tell you what the variance is, right? We can see here that the variance is quite large for group 1 and significantly, well, not significantly, but much smaller. We're trying to see if it's significantly smaller for group 2. There's a p-value that gets spit out, right? So that's, in other words, the probability that I would see this kind of an extreme in the variance purely due to chance. Okay, and it's saying that the probability, in essence, that the variances are the same is less than 1%. So, in essence, it means that we would reject the null hypothesis, because the null hypothesis stated that the variances are the same, right? We would reject it in favor of the alternative hypothesis, which says that they are different, right? Which you can see here, the probability that they're the same is less than 1%. Okay, I would do then the same thing for group 1 versus group 3. So again, data tab, data analysis, f-test, press OK. I can leave the variable 1 range the same because that's already highlighted group 1. I'm just going to change the variable 2 range to make it group 3. Press enter. Leave everything else the same except this output range. I'm going to change that to put it below this table. So I'm just going to select Q14, press enter, and click OK. Here, again, you can see the means are pretty much around about 10. Again, the variance here is is probably even more dramatic, right? The probability that the variance here is the same as the variance here is incredibly small, right? You might see it in the scientific format. If you don't like that format, just go to the Home tab, go to the number formats, and change it to the number option. Then just increase the number of decimal points, and you'll see that's in a more familiar format to you guys. Okay, so again, here the probability here that they are the same is even smaller than it was for group 1 versus group 2. And then the last one is just go to data again, data analysis. Now I'm comparing groups 2 to groups 3. So I'm going to change this variable 1 range to group 2, press enter, and variable 2 range should already be group 3, and you can see it's already highlighted. So I'll just press enter. I'm going to change this output range to put that information below that other table. Press enter and hit OK. So now this is group 2 versus group 3. Again, means are very close here, but the variances are again drastically different, right? A little bit better than what it was for group 1 versus group 3, and that's again reflected in this p-value, which is again less than 8%, right? Only 0.002616, which is very small. So they are significantly different. Again, we would reject the null hypothesis in favor of the alternative hypothesis. But again, visually we saw that, but now we proved it with our statistical technique using the f-test. Okay. We also have to run this because we'll need that to determine which of the t-tests we need to run. The t-tests look for these differences in the means. So again, your null hypothesis there states that the means are going to be equal, and then we're going to try and see if we can build any evidence whether or not to accept or reject that null hypothesis. Okay. Intuitively, again, we already know these means are pretty much equal, right? I've set it out that way that they're pretty much equal to 10. So intuitively, if we compare it, there shouldn't be a significant difference in the means because in essence they are the same. But we'll see if that builds up or if that holds true when we run the t-test. So again, go to data analysis, go to the data tab, go to data analysis, then you're going to select the t-test. And there's a couple of t-test options, and one of the reasons that we ran this f-test is to determine whether the variances were the same or not. And what we've determined is that the variances were not equal to each other, so you'll take the t-test assuming unequal variance. Click OK. Again, I'm going to choose which groups to compare. I'm going to compare group 1 to group 2. So I'm just going to highlight that, press enter. Again, I'm going to select a different, again, put the hypothesis mean difference to 0. That is the assumption that we're basing it on. Highlight the labels option and then just select an output range. I'm going to select U3. Press enter and then hit OK. I'm just going to create a little bit more space over here. Again, we can see here that what the means are, what the variance is. In other words, it's replicating some of the data that we've already got. And here we're going to be interested in the p-value for the two-tail t-test. And you can see here it's 0.9. In other words, the probability that these two means are the same is approximately 90%. Okay, so here we fail to reject the null hypothesis because remember the null hypothesis says that the means are the same, and we don't have enough evidence to reject that, right? The probability that they're the same is 90%. And again, we could visually see that, so it's nice to see that that comes through in the statistics. I need to do the same thing for group 1 versus group 3, so I'm going to go to data analysis again, select the t-test for unequal variance, because again, when we did the f-test for that, we had unequal variance in that. So I'm going to click OK. I'm going to keep it as group 1, just change this group 2 to group 3 now. Press enter. Keep the hypothesized mean differences the same, labels ticked, and I'm just going to change the output range to put it just below there. Press enter and hit OK. Again, you can see the means here, and the p-value two-tail says that the probability that these two are the same is 97%. That's even greater. Alright, so this mean versus this mean is not statistically significantly different from each other. Okay, and then lastly, I'll do group 2 versus group 3. Okay, so I'm going to change that variable run range to include group 2 now. This should still be group 3, so I'm just going to double check that, and then I'm going to change where I put that information just below that table again, press enter and hit OK. So again here, the probability that they are the same, in other words the means are the same, is 74%. Okay. And I think I might have made a mistake here just in terms of what I was referring to, group 1 versus group 3, so the mean here versus the mean here, not the mean here versus the mean here. So just be careful of what groups you're talking about. Apologize for that if that was confusing. So in essence, the means for all three groups are not statistically significantly different from each other. We do have to be careful in terms of potentially making a type 1 or a type 2 error. In other words, incorrectly accepting the null hypothesis or failing to reject the null hypothesis because of these multiple group comparisons that we're doing. In order to correct for that, we typically do a Bonferroni adjustment. In other words, we do an adjustment to these p-values that we've calculated based on the number of group comparisons that we're doing. But again, that's a little bit beyond the scope of what it is that I'm trying to teach you guys at this point in time. For now, this will suffice. Okay, so that's the long way around it. How can we make this a little bit quicker? Because again, this is just three groups and you guys might be comparing multiple variables. Like I said, all the different anatomical landmarks of the feet and so on and so forth. So first of all, we can run the f-test. And in order to do that, I'm just going to press equals, type in f.test. So there's a function within Excel that will allow me to run that. I'm going to press the tab button, which is just going to have this open parentheses over here, and it gives me a kind of request in terms of what data do I want to put into this f-test function. So it's going to ask for two arrays. Now I'm not going to highlight the label in this instance. I'm just going to highlight the numbers within that specific group. So I'm going to highlight the numbers in group 1, press comma, highlight the numbers in group 2, then close the parentheses and press tab. And now it's going to spit out a value for me. This is the p-value that we calculated in this example. Now you might say, well, hang on, this p-value here doesn't look like the same as this p-value here. But in essence, this is a one-tailed test, and what we in essence are getting here is the two-tailed p-value. So this is two-tailed. So it's looking at either end of that distribution. And if I want the one-tailed version of it, all I need to do is to say equals this value divided by 2. You can see here now the p-value is 0.00654, which is what I see over here. So that's kind of good to see. Okay, so this is now, like I said, what makes it quicker is that once I click on that cell and I click in this formula tab up here, you can see it automatically highlights the two groups that are compared. So if I want to compare group 1 to group 3 now, all I have to do is just make sure that when I move the mouse on this edge over here, it highlights that group. I click and drag it across, and then click at the bottom corner again. Notice how my mouse cursor changes from that plus sign to this diagonal arrow. Just click and drag it to just include those numbers. then press tab. Now you can see it's updated it automatically, and I've got the one-tailed version over here. See if that compares to the p-value over here, and indeed it does. And then the same thing if I want to compare group 2 to group 3 now. Again, I highlight that cell, click in the formula tab, and just click and drag across, click and drag down, press tab. Now it's updated again, 0,00262, and that should coincide with what I have down here. Awesome, so that seems to have saved a lot of time. Same thing is true with the t-test. So t-test will be like so. In this instance, I will type in equals t.test, press tab to get that open parentheses. Again, I will enter two arrays with my data for each group. So again, highlight group 1, comma, highlight group 2. Now there's some additional requirements here. I'm going to press comma. Now it's going to ask for what kind of a tail do I want to look at, a one-tailed distribution or two-tailed. I want to go for two-tailed, so double click on that, press comma, and then it's going to ask me the type of t-test that I want to run. Well, we went through the f-test to determine if the variances were equal or unequal. In this case, they were unequal, so I'm going to use the t-test assuming unequal variance. So double click on that, and then close parentheses, press tab. So in this case, I get this 0.904, which is going to be pretty similar to what I have over here. Right, so the same two-tailed comparison numbers are getting spit out over here. Again, if I want to compare group 1 versus group 3, again, click and drag across, and then click and drag up, press tab. Just double make sure that in some of your instances it might be equal variance or unequal variance, so just make sure to update that over here. You'll always keep it as the two-tailed, but this last variable over here, just make sure that you update it depending on what your f-test value said. Okay, press tab, and now you see it's going to be 0.9717, which is again what I had down here. Okay, so you get the general gist of what it is that we do. You'll report that in your write-up. So the way in which you would write it up is f test, comma, and then just say p is equal to whatever this two-tailed value is. Okay, so I want the two-tailed values for all of these statistical tests, so that's equal to 0.005233, and press enter. So this is what you'll write in your report write-up. Same thing for the t-test. You'll write it this way: t-test, comma, p is equal to, and then that value 0.97179. Okay, so just make sure that this is representative of what it is that you're talking about. So if this is now the values for the group 2 versus group 3 comparisons, right? And same thing here. So make sure you see in this case it's not, so I just want to make sure I update that to compare group 2 versus group 3. When I press shift there, that's not updated. I just need to make sure that that updates. Okay, so I'll just do 73977. If you want to make sure that this updates automatically as that changes, just so you make sure that you don't make a silly mistake, there is a way to do that. You can say is equal to, and then just do these double colons, and then write in there t test space, comma, space, p is equal to space, and then double colon again, and then use that ampersand button, which if you press shift and the number 7 gives you this ampersand, and then you can just click on the cell where your t-test value is, and you should be able to press shift, and it should write it out there. You can see now it includes all these decimal points, which is something that doesn't look very nice. So again, if I click on that cell, all I'm going to do is enter a round function here, open parentheses. I want to round this number to 4 decimal points, close parentheses, and there you can see that's a little bit nicer. So now when I change this to say maybe I want to compare group 1 to group
3, this t value should update, and then this over here should update. So if I press shift, that's now 0.9718, and that you can see now is updated there automatically. Now if I wanted to compare groups 2 versus group 3, again, now it updates, and that automatically updates. Okay, so it makes life a lot easier. And I think that's pretty much it in terms of the inferential stats that I want you guys to be able to run. So the key thing here is t-test. You can either do it this way, or you can do it this way. Whichever one works for you is fine. As long as you're reporting the numbers correctly, I'm happy. And as long as that's in your write-up, you're good to go. All right. See you guys on the flip side.